Okay, I think we are live. Welcome everyone. This is the first MSR tutorial. I am Marco D'Ambros. I will be chairing this session. It's my great pleasure to have Alberto Bacchelli and Maurício Aniche here presenting the first tutorial called PyDriller Ready to Grow Together. Alberto Bacchelli, Professor Alberto Bacchelli is Associate Professor at the University of Zurich. He got his PhD working with Professor Michele Lanza from the Università della Svizzera Italiana. He also interned at Microsoft twice, and it's also worth mentioning that last year he won a MSR award for his career and contribution on code reviews. Maurício, he is assistant professor at the University of Delft in the Netherlands, and he got his PhD from the University of São Paulo, Brazil, and before he also worked as a developer for a number of years on many companies, and he also found one. So, Alberto, Maurício, the stage is yours, and let's see how to grow together this PyDriller.
Thank you very much, Marco. So
thank you so much, Marco.
So Maurício, you start.
The floor is mine. Yes. Yep. Hi, everybody. Thanks for joining our tutorial on PyDriller. PyDriller was this tool created by Davide during his PhD, together with me and Alberto, and we have the pleasure to present this tool now that Davide is working for Facebook. So the goal of this tutorial is basically to explain to you why we decided to create PyDriller, to give you some intuition on the main elements of PyDriller so that you know how to use it, show you 3 or 4 real-world examples, and finally explain to you, if you want to contribute to PyDriller, how you can do it. So hopefully we can do this in 50 minutes. First of all, why did we create PyDriller? Maybe a little bit of the history of PyDriller. The version before PyDriller was called RepoDriller. It was a Java version very similar to the one you know now in Python. And at some point, we just made it in Python because Python is an awesome language. It removes all the verbosity of Java. So this is one thing about the technological evolution of PyDriller, but the creation of RepoDriller right back then was fully motivated by the fact that it was pretty boring to extract data from Git. You would have, people using bash scripts doing Git commands directly to extract commits and authors and source code, diff, etc. And those bash scripts are just very complex. If you wanted to use some tool, you could use JGit or Git Python or whatever a Git layer that you have in your language. That was okay, but if you're using those tools, they are so low level that they require you to configure a lot of stuff to just extract basic information. So, and you would then start to copy a lot of boilerplate code from one project to the other. So then we kind of decided, let's just put those repetitive things in a simple framework so that people focus on what really matters, that is to extract the data that you want. And as I said, we started with the Java version, which was just a bit more verbose, maybe a little bit more, it took different design decisions. PyDriller is definitely much simpler, much easier to use, and you're going to see that with 1 or 2 lines of code, you can already start to get data from Git repos. So that was a bit of the motivation behind it, and so then I'm going to give the floor to Alberto. He's going to start with section 2 of this tutorial. So I'm going to stop sharing my screen.
All right, thank you, Maurício. Let me share my screen instead. Okay, so you should see it now. Oh, you also see the cursor. That's great. So in this tutorial, we really want to show you how easy it is to use PyDriller. And first of all, we're going to show you what you need to use it. So here we have written a bit of Python code that is needed to import everything we need in this system, in this tutorial. As you probably can see, this is running on Jupyter Notebook. This is the Google version of it. Of course, you can use normal Python, but for us it was easier to create it this way so that we can share a PDF and the notebook itself with you at the end. So what we need here is a bunch of imports that we need to use Jupyter Notebook and PyDriller. So far, it's just the basic things. We import the system, data, and collections, and also matplotlib, because we're going to show you a couple of graphs using the data that we collect through PyDriller. Okay, how do you install PyDriller? Well, if you are in any Python environment, you probably have pip, and this is how you run pip to install PyDriller. If you have a Jupyter Notebook, you have to use this exclamation mark so that it uses the system, and then it downloads PyDriller for you, and it installs it for you. Once you have it installed, you can actually import it. It's simple as that. So you pip install PyDriller and import it. Okay, the last bit of the configuration we need for today's tutorial is to have access to a code repository that we can, a Git repository that we can actually mine data from. So what we did here, we copied the repository of Mockito. If you don't know Mockito, it's a framework for testing in Java. This is the website, the GitHub repository of it. It's a mocking framework for Java. It's reasonably sized, so we decided to use it for this tutorial. So what we did was importing that repository somewhere in our Google Drive. And then with this line, we basically mount this folder to our Google Drive.
Sorry, Alberto.
Yep.
Could you make the font a bit bigger?
Oh, yeah, absolutely. Let me try to do that. Is it large enough now?
Well, for me, yes. Let's see. Yeah, I think it's fine. Thank you.
Okay, thank you. Okay, so this is everything we need. Basically, we need to install PyDriller, we need to import it, and then we need somewhere a repository, a Git repository that we can mine. So now let's see what we have to do next. So the entry point, the starting point of using PyDriller is to create an object of class repository. This object allows us to model a Git repository and do things with it. And it's as simple as running this line. So we say we create a new object of type repository, and we specify the path of this repository. And you see now this was running very quickly. And now that you have this repository, you can do nice things with it. So as a very basic example, maybe you want to see all the authors that committed to this repository. You want to see their name and which commits they did. So how can you do that? Well, it's as easy as starting a for loop in this way, where basically you specify that you want to traverse the commits of this repository. And then you have in your hands a commit object that you can, for example, invoke to get the information about who the author of this commit was. And this is as simple as running something like this. So in this way, I can print the name of all the authors that happened to have committed in this repository. Let's have a quick look at this. You see, it's printing out all the authors. I'm going to stop it here, but that's just to give you an idea. So we traverse all the commits of this repository by calling this simple method, and then we are able to see all the authors that actually created those commits. You can have other information, for example, the hash and the date in which the commit was created. It's as simple as calling the right method on the object commit. Okay, if there is any question, Marco, please let me know. I'm not paying too much attention to the chat. but I'm happy to stop and answer your question. So let's say that we just want to see the hash and the name of the author for 20 commits. We can run something like this. We get 20 commits. Once we get to this number, we break. So let's have a look. Okay, and this is the results. We see the commits and the authors that created it. Okay, the next step that you may be interested in is which files were modified in particular commits. And this you can get, again, by traversing the commit. So we start another loop here. And this time, we know that a commit contains normally a bunch of files that were modified. Normally, it's at least one. How can we access these files? Well, what we can do is the following. We can, for example, do like this. So in this way, we get a commit, and inside this commit, we get all the modified files. And this modification contains all the information about this particular file, so that was modified. So let's say that we want to just print the diff. What happened in that particular commit? So let me break after just one commit. So let's see what happens here. Okay, so what is happening now is that this was a very long commit. Maybe I should pick another one. How can I do that? Well, one thing I can do is whenever I create the repository object, I can specify, I can filter around some dates, for example, or I can filter around some specific features of the commit, specific files, and I can even filter to make sure that I only traverse a single commit. So if I create an object of type repository, by specifying this filter, I say I basically get only one commit. So in this way, I will have a repository with one commit. I will traverse this particular commit, and then I will print all the modified files in that commit. Let's have a look. Okay, so you see that now the execution stopped in a much quicker way because we have a shorter commit that we're dealing with. And here we see the information. It's the diff. But it's a bit hard to see this properly. So another thing that we can do is we not only print out the diff, but we also specify which file was modified, because here you don't see exactly which file was modified. You only see the context of this diff. So if I add the file name that I get from the modification, I get more information. Okay, so now we can even print out which file was modified, the diff, and also we see that two files were modified, so it was not actually the same one.
We got one question, which is if this filtering by commit hash helps performances.
Yeah, normally it helps performances when we do it here at level of repository. Another way would be to basically start traversing all commits and checking if we reached this particular hash and printing the information out. In that case, of course, it wouldn't be as efficient as it is now. Another comment that I would like to make around this topic is that we are now playing with this free version of Jupyter Notebook that Google provides. So what you see is way slower than what you would experience if you were using PyDriller on your own machine, even if it's a simple laptop.
A follow-up question is traverse commits iterator, or it's already a list?
It's if I remember correctly, it's an iterator. So everything in PyDriller is lazy, meaning that it tries to give you information only when you need it. It does not pre-compute anything for you. So if I remember correctly, this traverse commit is a generator. So it yields the results for you.
So there is one more question, but I think it makes more sense to answer this at the end because it's more about usage for mining tasks. So
okay, good. Then since we started talking about a little bit of filtering here, let's see another thing that you can do. Let me add another point. So if you look for PyDriller on Google, you find a very comprehensive documentation. It gives you a lot of information about, for example, the repository object, the main class of PyDriller, and all the things that you can do. For example, what we have seen here is that we can select a single commit range, but we can do more sophisticated filtering. So we can specify dates from which we want to start traversing, commits, tags, and when we want to stop. Okay, so another thing that we can do in terms of filtering is, for example, that we can filter on specific branches, on specific authors, and we want, for example, certain releases. Another thing that we can do is that we select only the commits that modified a particular file type. This means that, for example, if I have a commit that modifies, here in the example we have .java, then this will be integrated will be traversed. But there could be other files in the same commit, and these we would cover anyway. So with this only modification with file types, we get all the commits that have at least one, for example, Java file. So let's see this.
And because, just one remark, Alberto, we were talking about performance. This last filter you just shown, only filter by file extensions or something. This is right now the slowest one, because this one, PyDriller really needs to go commit by commit. So we're still not repassing this to Git. So this one is a bit slow, but the others, as Alberto said before, they are pretty fast because we basically repass the filter to Git, and then Git is very fast.
Absolutely. Thank you, Maurício. So this is an example in which we open a repository object where we say we only want the commits that touched at least an XML file, and we want them to be starting from 2020. So this way, we can just explore this particular case. Let's see what happens in the case we run this on Mockito. As you see, this is a bit slower. It's coming. While it's coming, okay, there they are. Actually, as it's going to stop very soon, there are only 2 commits that satisfy this filtering, so that touched at least one XML file since 2020. Okay? As I mentioned before, you can find all the documentation about PyDriller in this page. In particular, the most important things that you want to look at if you start playing with PyDriller are the repository class, the commit class, and the modified file class. And this is everything you need to know to start with PyDriller. So in the remaining part of this tutorial, Maurício is going to show you a couple of examples in which we basically mine software repositories, mine code repositories by using PyDriller to answer some common questions. Maurício, you want to take over, or I continue with the committers of a project?
I think you can do the first 2, and then I do the last 2.
Okay, so a very common question that we often answer when we are mining software repositories is, who are the committers of a project? This can be, for example, because we want to replicate something like ownership studies, or, for example, because we want to decide which projects we want to include in our repository studies. For example, we want to make sure that we have a certain diversity of projects that have a couple of developers, 5 or more, or even larger teams. So how can we quickly find out who are the committers of a specific project by using PyDriller? This is as simple as playing a little bit with a couple of calls to PyDriller and Python. So we again create the repository object by passing Mockito. And then what we do here, we use a list comprehension in Python. Basically, we traverse all the commits in this repository, and we collect all the names of the authors that ever committed to this repository. And then we transform this list into a set to remove duplicates. So let's see how this runs. You see, this was much, much faster than the previous command, because if you just run this without any filtering, PyDriller can use basically Git Python in the backend as is, and it can go very quickly. And this is the list of all the authors that ever committed to this particular repository. Any question about this? No? Okay. So once we talk about committers, another thing that often comes out when you're doing analysis of code repositories is, for example, who are the people who committed the most? Okay. So again, let me show you how we can do this by using PyDriller. So here we use the same list comprehension, but instead of transforming this list into a set, we're going to use a counter. What does a counter do? It basically tells you for each element that is the same, how many times this appears. So with 2 lines of code, and actually only one of PyDriller, we are able to see who are the 10 most prolific committers in this repository. Okay, and this is the list. So we have Faber, who committed almost 3,000 times, followed by Breeze with almost 600, and so on. And we also see, for example, that we have something that looks very much like a bot. I like lists very much, but I like graphs much better. So here I can show you how we can use matplotlib very quickly with this information. So we are going to create a graph that basically shows bars with the top committers, who they are and how much they committed. And we're going to pick the 15 most prolific ones. So this is just to show you, if you know another library like matplotlib and Python, how quickly you can get this information displayed. Okay, now we have this nice graph that shows you the 15 most prolific authors. So you see that it looks like a power law distribution, but definitely we have one outlier. Probably this was the first creator of this system. And to conclude this example, another thing that could be interesting is to know whether we have some committers who only committed something once. Maybe these are people who wanted to make some minimal changes to Mockito, and then they left. So how can we get the single contributors? Again, it's a very simple mixture of Python and PyDriller. So we have this line where, again, we use list comprehensions. We get all the committers. For each committer, we already retrieved the name and the number of commits, and we only pick out the ones that have one commit. Once we have these single contributors, we can print them out.
Alberto, one question that is relevant for what you're doing now is,
yeah.
Is there a way provided by PyDriller to automatically infer the bots?
At the moment, no. So the philosophy that we have in PyDriller is to keep things as simple as possible, to give you the possibility of adding these analyses. We do have some initial analysis already implemented in PyDriller. Let me show you very quickly. So we have PyDriller, we have, I think it was metrics. So we have these classes, they already implement some process metrics that you can use. So for example, commits count, contributors count, also things that I'm showing you. If I remember correctly, we don't cover that yet, but this would be a very nice addition to have in PyDriller.
Okay, and following up, there is also a way to like merge or disambiguate contributors when you have like some sort of aliases. Is there an algorithm to do this, including PyDriller?
Not included in PyDriller at the moment, again, for simplicity. But I may be not remembering it correctly. So contributors count may do some de-aliasing here. I would recommend that you have a look at this specific class here.
Okay.
Otherwise, again, it's just a bit of Python code that you can write.
There are more questions. Do you prefer to continue and answer in the end, or I mean, I wonder, like in terms of timing, how?
Yeah, so I would say unless they're about clarifying things that I'm saying, I wouldn't take more than one question now, and we can take more later.
Okay.
If that's good with you. Okay. So here we print how many. So we have 158 authors out of 261 who committed only once. And there may be repeated authors. We did not do any de-aliasing here. And the first 10 are these ones. Okay. And so this is about playing a little bit with authors. Another thing that you may want to do is to see, for example, what are the hotspots of the system. So what is a hotspot? Normally it could be a class that is changed quite a lot in your system. And normally this could be an indication that this class may be, well, for sure is change prone. It may also be defect prone, or this could be a very nice place where you want to do some refactoring. So how can we find the hotspots in the system by using PyDriller? I've written a small script here, and I'm copying it here fully, and then I'm going to show you, explain you how it works. So we use dictionaries and date and type. Let's see. So we prepare an empty dictionary that contains all the modified files. And then to make this tutorial not too long, we only focus in the last year, and changes happened in the last year. So what we do here, we say we create a new repository object, and it should start traversing commits since last year today. And we only get commits that modified Java files. Okay. Then what we do, we traverse all these commits, and every time we hit a commit, we get all the modified files. If the modified file is a Java file, this is important because with this filter, we get all the commits that modify at least one Java file. But if a commit modifies one Java file and 2 XML files, in this for loop, we're going to also hit those 2 XML files. So, but we only care about Java ones. So what we do, if they have this extension, then we add them to our dictionary. And if they're already there, we increase their counter by 1. So I run this code quickly. This allows me to breathe a little bit and also to answer a question if there's any, Marco.
So I think I lost it. Sorry, one moment. So the question is, if you still have in PyDriller access to some sort of low-level API from Git Python, for example, to perform git blame on a specific revision?
I lost the beginning of the question.
So if in PyDriller you provide access to Git Python, so low-level Git Python to perform more advanced operations like git blame on a specific revision.
So git blame is already supported by PyDriller, and definitely it uses git Python. What we recommend doing is normally most of git Python is covered by PyDriller. Rather than exposing the git Python API, what PyDriller does is it makes it very easy for you to add any functionality that you know of in git Python. So we're gonna see this a bit later. So git blame is already there, and we're gonna show you a pull request that actually changed the way in which we can compute the blame by using PyDriller. Okay, now
Can I make a short remark? A huge
Yes.
part of the PRs we receive in PyDriller are about adding Git-specific stuff. So if Git supports this crazy flag that makes things better for your analysis, it's very easy for you to send a PR, and we integrate this into PyDriller. So that's how we have been doing it.
Yeah, and write tests, but more on this later. So now we see how many files that were modified with collected. Okay, and we see we can draw a graph that shows the 20 files that were modified the most. Again, we use the same type of bar chart, and this is how it looks like. So we have this Java class, which was modified 17 times in the last year, followed by Mockito.java, and so again, it looks like a power law distribution. Many files are just touched once. Okay, Maurício, I think it's your turn now.
Yes. Okay, so let me share my screen. Give me a second, just organizing myself. Do you see my Jupyter Notebook with the 2+2, right?
Yes.
Great. So
Maurício, sorry, maybe make the font just a bit bigger.
A bit bigger. I'm in a very big display, so let me know when it's good enough, okay?
I think this is perfect.
Great, great. So the third example we wanted to give is about logical coupling. Logical coupling happens when two files are modified together, right? Maybe they don't have they're not coupled in a structural manner, but they're coupled in a logical manner, right? And this was quite of a popular research line back in the days. Give me one. Things, folks. But so, and what I want to show here is that even those more complicated things, you can do with PyDriller in a very simple manner. So I'm gonna do the first thing you always have to do with PyDriller, right? You have to instantiate the repository class. And here I'm starting in 2021 just to run faster, but you can run this in the entire repo. And I'm going to do a very simple algorithm for this, right? So I'm going to traverse all the commits. So traverse commits. And I'm going to visit the modifications, right? So all the modified files, right? I'm going to just then do another loop on the same thing because I want to kind of do all the combinations. Maybe Python people will now curse me because there might be a better way to do this in Python, but that's for later. And what I'm going to do is I'm going to basically combine the two names. This is a very naive implementation of the algorithm, but just to demo it, okay, folks? So bear with me. I'm going to have this coupling dictionary where I'm going to just simply do A+1. So whenever two files happen together, I just created this key that is basically the two file names. And this dictionary contains the key, and then I just do a +1. So let me just create this dictionary here. I'm going to actually use the counter class like Alberto did back then. And of course, I'm going to skip, because if the file names are the same in the two loops, we just continue. So We loop all the modifications 2 times because we want to get all the combinations. We build this very naive dictionary in a better implementation. Maybe you can even put this into a database. That gets me actually to a question I received yesterday in one of the sessions. What's the difference between PyDriller and all the other libraries? PyDriller is kind of a framework, right? And this allows you to do whatever you want. So if you just want to connect a database here, you can do that. This is different from, let's say, other data sets like BOA or GHTorrent, where the data is there and you query it. You get this into, I don't know, a JSON format, and then you do stuff. Here it's more of a framework where you plug your analysis in the framework, right? So hopefully the god of live coding is with me today, and this is going to work. So I'm going to print the 20 most common logical coupled files. This might take a while, so meanwhile, let me go to my notes and copy the matplotlib information. Okay, I'm going to count to 10, and if it takes more than that, I'm going to just show you the cached version we have.
We can take a question in the meantime.
Yeah, definitely.
So there is a question about the documentation of PyDriller seems to be for version 1, whereas on GitHub there is version 2. So to which extent there are differences, and how much is this tutorial applicable to version 2 rather than 1?
Yeah, good question. I think we forgot to update the version because I think in the title of the page it says PyDriller 1, but the documentation should be updated for version 2. The main difference between version 1 and version 2 is that version 2 supports multi-threading. So you can run your study and you can tell PyDriller, use all the cores I have, and PyDriller will try as much as possible to split the work. That was mainly the big new feature in version 2.0. So everything that we are saying here works in both versions. And by the way, we are using version 2.0 here. One of the small things we changed was the name of this attribute method over here. So this is version 2. Yeah, okay. I got the results back. Of course, it was just this year. So you see very low numbers here. If you run this for longer, you're going to have way interesting results. And then you can, again, as Alberto showed, you can easily plot stuff if you know matplotlib a little bit. Then you can come up with something like this. And then you can see that Mockito, JUnit Runner, and instantiator.java are often committed together 4 times. You see, this is something my stupid algorithm didn't treat, so those are the same. So this is actually 8 times, right? Or no, it's 4 times because of the loop. So my very naive algorithm didn't treat those things well. Someone can help me implementing a better logical coupling thing. But this, again, this is to show that you can just plug and do whatever you want with the data. And to be honest, that's something I do a lot. So again, another advantage of PyDriller in comparison to the others, because usually you don't care so much about the raw data, but you want to process this data in a way that makes sense for your study. So I usually tend to mine the repo, get the data, do whatever transformation in the data I want, and it's pretty cheap to do, right? The information is right there. You convert it to a better data structure, and then you store it. Okay, then maybe we have time for one more example, and this is also to demo another feature of PyDriller. That is, PyDriller has built-in code metrics. So if you want, you can calculate, for example, the complexity, the cyclomatic complexity of a class. So let me do this. Again, I'm going to create a new repo just for the sake of simplicity. And given that our time is running, let me copy the code directly and I will explain. So basically what I do here is I create a simple array complexity. And what I want to do is I'm going to follow all the commits from 2018 onwards. And I'm looking for all the changes in this Mockito core.java class, right? A random class I just picked the name seems important, right? So this seems like an interesting class to follow. And whenever we have the class, right, you see the M modified object here, I just call the complexity method here. And this method will, behind the scenes, called Lizard. Lizard is a Python framework that calculates code metrics on top of many different programming languages. So that's another advantage. It kind of doesn't matter what programming language you're using. PyDriller will probably be able to calculate the complexity of the file. And I'm just putting this into a simple array because I want to follow the evolution of the complexity over time. So that's what I'm going to do. Running again. Maybe time for a question, Marco.
There is one which was already answered in the chat, but maybe you want to comment on that as well, which is how was PyDriller used for in research for actual mining task? So it was answered with a link to Google Scholar publications where, you know, there is a list, but if you want to say something in addition.
Yeah, I love this question because maybe the question is, we're doing so many simple stuff here. Can this be used for research? Yes. And that's the beauty of PyDriller. With a few lines of code, you can get all the data that you want. And yeah, production research code looks like what we have here. You traverse the commit, you look for stuff that you want, you do the analysis you want.
Yeah, in our group, we used it basically for every paper in which we need to do some Git mining. It's based on PyDriller. And it's downloaded a lot, but and we know that it has been used in more papers than Google Scholar says, because maybe the paper does not reference the publication behind PyDriller. So, but starting from Google Scholar, it's a good start to see.
Yeah, we're using it right now. Actually, in a study we are conducting, we are very curious about the evolution of a specific type of file in code repositories, and we're using PyDriller to find all the modifications in that file. We then get the version of that file back then, and we are studying the evolution of this file, right? And this is also a 5-10 lines of code script. That's the beauty. So it executed, and then you can see that somewhere in the life of the Mockito core, complexity was 37. In the last commit, complexity was 47. If you want to plot this, you kind of see that the complexity of this file is growing. In here, I plotted the hash. I could have date, right? The only thing I would have to change is probably from commit.hash to commit.date. And I would then get the date of the modification, right? So again, very simple. If you go to the PyDriller documentation, you can see, for example, the different stuff you can get from a file that was changed. And I think those are the important ones if what you're doing is dealing with source code. So you can get the source code, you can get the source code of the file before, right, before and after. You can get a list of methods. So if your language is supported by Lizard, we give you the list of methods before, methods that were changed, lines of code, complexity, number of tokens. And we are open to more contributions on this. So I guess this closes up our 4 code examples on how to use PyDriller in real life. I'm going to give the floor now to Alberto.
Maurício, and in these last 5 minutes, you will see more in the PDF and the Jupyter notebook that we're going to share with you. We discuss exactly how to contribute to PyDriller and what is a principled way of doing that. So let me share the screen again. All right, there you go. So we're going to see very, very quickly and just showing you the principles. So to contribute to PyDriller, my recommendation is to look for pull requests that try to do something similar to what you need to do right now. So for example, there is one that adds traversing configuration flags. So if you go in the Git documentation, this is basically, this is probably too small, right? There is this rev list, which lists all the commit objects in reverse chronological order, and this is what Git Python uses to allow PyDriller to traverse all the commits. And let's say you're looking at this and then you notice that something is very useful for you but has not been implemented yet in PyDriller. How can I add that? So there is this, for example, case here that basically looks at all the commits, including the head, so that they are listed in this traversal. That's just an example. So, and then there is another one which is called ---- remotes, which also looks at all the remotes that are not locally stored in your machine. So 1.5 years ago, these two options were not supported by PyDriller. So how can we do that? Well, let me show you what another developer did. So this developer created a pull request and explained what this pull request is about and explained why this is useful. So what he or she did was modifying, in particular, two files. The repository mining file, which is now called repository for simplicity, and it was as simple as adding these two configuration flags, adding the documentation to it, and by the way, you also fixed typo or ship, and again, adding this configuration somewhere else. Finally, he modified, or she modified, the conf.py file, which basically stores all the information about configuration that you pass to Git Python and Git, and added this information here. I have to go very fast, but the thing is, if you look at past pull requests that do something similar, this is a fantastic starting point to see how to do these things. Another very important aspect, and this is something we require a lot when anybody creates a pull request, is that tests are created. You can see here, I think Davide said, thanks for the PR and also amazing job in writing the tests. Let's have a quick look at the tests, because this is an important thing here. So what this author did, this author created two tests. This test was added to the commit filters file, which contains all the tests related to these functionalities. And there are two tests, one for the include refs option, and which is the ---- all, and one for the include remotes option, which is the ---- remotes. And you see that basically it tests that the feature was implemented well. One thing that I would like to mention here is that since we are playing with repositories, we have to have test repositories. And PyDriller already offers you test repositories that you can access when you write your tests. So if you go in the PyDriller main folder, you see that there is a zip file called test-repos.zip, and it had to be zipped because of, well, it would be GitHub within, Git within Git, so that would have been a bit more problematic than just creating an archive that contains these repositories. It's automatically unpacked for you when you run these tests, and if you open it on your machine, you see what kind of repositories are available. And branches not merged is one of these repositories. So the author opened this particular repository and used that to test the specific features that were created. The same thing here, there is another repo called PyDriller in the test repositories, and here again the test is using that as a way to test the pull request. Another thing you can do, you can
Alberto,
add,
sorry.
Yeah.
Just heads up that we are done in 15 seconds.
Yeah.
Not entirely sure what's going to happen.
Okay, very quickly. So if you need more repositories, you can add them to the test repositories. And we have 5 seconds. So I'm going to stop here and wait and see what happens.
See you on the other side.